Composite functions. Let me give you an example of composite functions in my life. We tend to travel a lot, and when we do, I'm the one who usually drives. When I drive, I like to have a big bag of candy to suck on to keep me awake. So I go to Wegmans and I go to the bulk candy section and I get myself a big bag of candy. When I go to pay for that candy, what happens? Well, when I go to pay for that candy, the first thing they do is they weigh it, and then they get the cost of the candy. So the cost as a function of weight is $2.25 per pound. So they take $2.25 and they multiply it by whatever the weight is, and that gives them the cost of the candy. However, that's not how much I pay, because after that I have to pay taxes. So tax is 8%, so I pay 1.08x, where x is how much something is going to cost. This is how much I pay in tax. So let's say I buy 3 pounds of candy. How much am I going to pay? Well, they're going to take cost of 3 pounds. That's going to be $2.25 times 3, which is a lot of candy, by the way. Oops. $6.75. And then they're going to take this answer, $6.75, and they're going to plug it in there to find my total cost. My total cost is 1.08 times 675. 729. All right, so that happens so quickly when you're at the grocery store that you don't even think about it. But that's really what's happening. To find out how much the candy is going to cost me, first they find the cost of the candy, and then they take that answer and they plug it into another formula which adds the tax and gives you the total cost. And that's what composition is. Composition is using two functions. We plug into the first one, we take that answer, and then we plug into the second one. And so the fancy math symbols look like this. If f and g are functions, and x is in the domain of g, and g of x is in the domain of f, then we can form the composite function FOG, where FOG means take the x number, plug it into g, and then you take the answer and you plug it into f. And the stuff about the domain, that's just saying that you really can plug in all the numbers, because if you got an equation where you can't plug in a number, well then clearly this isn't going to work. Alright, so let's look at some examples. F of x is 2x plus 3, g of x is x squared plus 1. Find FOG at 4. What this symbol means is take 4 and plug it into the g function. When I plug in 4, I get 16 minus 1, that's 15. And then I take that answer, 15, and I plug it into the f function. 15 times 2 is 30, 30 plus 3 is 33. So my answer there would be 33. Now, what happens if you switch the order? GOF at 4. Well, this means take 4 and plug it into the f function first. That's 8 plus 3, that's 11. And then I take that answer 11 and I plug it into the g function. So that's going to be 11 squared minus 1. 11 squared happens to be 121. 121 minus 20 is 120. An important thing to notice, when you switch order, you get very different answers. FOG at 4 and GOF at 4 are very different things. So you can't switch order here and get the same answer. All right, well, quite often we're not going to have numbers. We're just going to have FOG at x. What this symbol means is you start with the g function. That's 2x plus 3. And then you take that answer, 2x plus 3, and you plug it into the f. Oh, I'm sorry. I wrote that backward. G of x is x squared minus 1. Ugh, bad, bad, bad. All right, so I start with g of x. G of x is x squared minus 1. I take that answer and I plug it in for f, which means I go to the f formula. Wherever I see an x, I'm not going to write x anymore. I'm going to write x squared minus 1. So the answer is 2. I don't write the x, I write x squared minus 1, and then I still have the plus 3 on the end. So that's 2x squared plus 1. Distribute the 2 through, and then add the 3 and the negative 2 makes 1. Again, if I flip that around, if I do GOF, this time that means start with the f. This is what I started to do before when I screwed up. I start with the f, I start with 2x plus 3. I take that answer and I plug it in for g. So I go up to g, wherever I see an x, I don't write x, I write 2x plus 3. So I'm going to have 2x plus 3 squared minus 1. And we'll simplify this, we'll expand that out. I'm going to use a shortcut, but remember you would take 2x plus 3 times 2x plus 3 and do FOIL if you don't remember the shortcut. So that would be 4x squared plus 12x plus 9, and then the minus 1 on the end. Simplifying it, 4x squared plus 12x plus 8. All right, next we have evaluate two new functions, FOG at negative 1. Again, this would mean start with negative 1 and plug it into the g function. That would be negative 3 minus 2, that's negative 5. I take the number negative 5 and I plug it into the f function. That's going to be negative 5 squared. Negative 5 squared is 25. Determine an equation for FOG. All right, again, I start with the g. G is 3x minus 2. And I plug that into the f, which means I don't write x anymore. I write 3x minus 2 squared. And again, I think I'll go ahead and FOIL that out. That's 9x squared minus 12x plus 4. Part C, use the answer for part B to evaluate FOG at negative 1. Well, FOG at negative 1 would be 9 times negative 1 squared minus 12 times negative 1 plus 4. That's 9 plus 12 plus 4, which, not surprisingly, turns out to be 25 because we should get the same answer either way. Now, personally, I thought this was a lot easier. I thought it was a lot easier to just plug the numbers in. But sometimes we end up doing this. We find the FOG first, and then after we find the FOG, we plug in numbers. And we'll see some examples of that later on. All right, the next thing we have. Consider f and g defined by the following table. Evaluate each of the following, FOG at 7. All right, so these questions tend to really bother students because there isn't a formula. The good news is you don't need a formula. This is actually easier than having a formula, because this says take 7 and plug it in for g. Well, looking at the table, I go to where x is 7. If I plug in 7, I get 6. So it's not like I have a formula that I have to work out. So now I take 6 and I plug it into the f formula. So I go to the table, there's where 6 is, plug it into the f, I get 5. So the fact that I have a formula isn't a big deal. It's actually kind of simple. I like it, not having a formula. How about GOF at 5? That means start with 5 and plug it into f. So I go to 5, plug it into f, I get 8. So then I take the number 8 and I plug it into g. So I go to the table, there's 8, over to g, it's 9. Now this is kind of a strange thing, FOF at 6. That means we're going to take 6 and plug it into f, that's 5. And then I take that answer and I plug into f again. So I take 5 and I plug it into f, I get 8. All right, similar deal down here. This means take 8 and plug it into g, I get 9. Take that answer and plug into g again. So I have 9, go back to g, I get 8. So that one's kind of interesting. I started with 8, I ended with 8. Unusual, but that's okay. All right, the last thing we have in this section is what we call decomposition. What that means is I'm starting with the answer. This is FOG. We call it h of x, but this is FOG. I want you to tell me F and G. So that's kind of completely backward from what I did here. Here I gave you F and I gave you G, and I asked you to find FOG. The point is, look what happened. To find FOG, if you look at this step right here, G ended up being the thing that was inside the brackets, and then the F was what you do to it afterwards. Same thing down here. For FOG, G ended up being the thing in the brackets, and then F ended up being the thing that you do afterwards. The thing you do afterwards is square it. All right, so that makes these problems pretty easy when you recognize that. G should be the thing inside the brackets. G of x should be 4x minus 6. And then f of x should be, what do you do to that? You take the 4x minus 6 and you cube it. So f of x would just be x cubed. Now, the truth is, that's not the only correct answer. There are other correct answers. Let me give you another one. Another correct answer, this is kind of a silly one. F of x would just be x, and g of x would be 4x minus 6 cubed. If I were to take that and plug it into that, nothing changes. Another correct answer, this one's a little weirder, would be f of x is x squared. G of x is 4x minus 6 to the 3/2. All right, that looks kind of weird, but if I do FOG, I would take this, 4x minus 6 to the 3/2, and then do f to it. And f says square it. Well, when we have a power followed by another power and we multiply them, and when you multiply them, you just get 3. All right, the point is there are an infinite number of correct answers. I could sit here and play with these exponents all day long and get correct answers. This is the one we really want, though. And the reason we kind of want this one is that things can't be decomposed anymore. There's your 4x minus 6. You really can't do much with that. And then an x cubed. All right, this one. This one's a little unusual because there isn't a parenthesis, but you got to think of order of operations. If I were to plug in a number, what would I do first? Well, what I would do first is I would do the adding, and then I would do the power. So that tells you how things should be. G of x is the thing you would do first. And then f of x is what you would do to that. So you would take that and put it up in the exponent. And finally, this last one, you got kind of the same thing. Think of order of operations. G of x is the thing you would do first. And then what would you do to that? Well, what you would do is you would put a 1 on top and put that thing down on bottom. All right, so that's it for this section. Kind of a shorter one, which was nice, especially after some longer sections that we've had. Only one video for this one, so you're ready to go on and do the work now.